Good afternoon and welcome to the Manufacturing Live session on additive manufacturing with Stefan Zimmermann and Raul Cuadrado-Cubas from Atos. You may use the Q&A function to post any questions you have for us. We will take time to answer all of them at the end of the session. With that, hand over to Stefan.
Thank you, Felix. Good afternoon also from my side. So I will give you, first of all, an introduction into what we do with additive manufacturing. Additive manufacturing is a growing market, growing application, as you can see here. So this is an overall figure which shows the revenue forecast for additive manufacturing, all different kinds of industries. So we should be heading from $7.5 billion in 2017 until $35.6 billion in 2024. That's a huge leap, 380% predicted growth. That is driven by many, many different industries, from automotive to aerospace, oil and gas, but also healthcare. So, and the food industry playing more and more role also in process industry. The benefits that are realized by additive manufacturing are, first of all, development time reduction, using in prototyping, for example, by about 75%, faster manufacturing, and also more individual manufacturing that is possible, and also faster repairs, because it will also see an application in after-sales service and in the spare parts business. And endless flexibility in design, because additive manufacturing has the advantage that almost every kind of design is possible to be manufactured using it. So what we see today is that in certain industries, it's still a little bit in its infancy. So it's used mainly for prototyping to an extensive level, for example, because in the automotive industry, for example, we can skip, providing models that take long to be manufactured. So you can easily do that from a 3D model coming to print a prototype. There are certain areas, for example, in teeth implants, where it has already 50% market share, and that is going to grow. And the intention or the target at Atos was to say, okay, how can we bring additive manufacturing out of this infancy in a more industrialized mode? How can we industrialize additive manufacturing and make it usable for our clients in a more industrial mode here? So our offering here is then going into the direction that we say, what is it that our customers need? First of all, it is 3 blocks that we are currently bringing to the market, starting with a consulting offering, the methodology for additive manufacturing, because what we sense is that a lot of our clients are still in their infancy, starting to think about what can be done with additive manufacturing, in which areas can I use it for spare parts manufacturing or even for new parts manufacturing. What is my strategy using additive manufacturing? What are additional applications of it compared to conventional manufacturing, or what are areas where I can say, okay, I replace conventional manufacturing by additive manufacturing. And therefore, the consulting offering includes a maturity assessment to say, okay, that is where the customer is. Also, what are parts that are suitable for 3D printing or additive manufacturing. It also includes the offering or the proposal of proof of concepts or proof of value, where this can be tested and evaluated. and where we can also say, okay, what are areas for improvement, and also what does it really cost? Is there some benefit? To the contrary of conventional manufacturing? An example which you see on the right side here is a part which is an automotive part. It's a hook in an engine bay, an engine mount. So it's now conventionally manufactured in masses. The customer said, okay, if we do that, if we just exchange conventional manufacturing by additive manufacturing, there's no business case. So we could prove by changing the design, which is only possible by additive manufacturing. There are certain additional characteristics brought to it. For example, it's much lighter and more stable, and also better suited to fill the engine bay, for example. The additive manufacturing or additive IT platform is a platform that is governing all additive manufacturing activities, that is processing additive manufacturing orders, integrating all different kinds of players in the ecosystems, own printing capabilities and facilities, but also external and partner facilities in here. We can not only manage the creation or the printing of new parts in the production process, but it is also suitable to govern, for example, spare parts printing, meaning that you have a client like an airline that wants to print some of the parts in the future themselves. Instead of procuring that from an OEM like Boeing or Airbus, and this governs the complete process, including the access to the PLM system of the manufacturer, and also the IP protection. Predictive monitoring system is focusing at the quality. Imagine yourself being part of a regulated industry where you only have certified parts. Again, the example of the for example, of the airline and the aerospace industry. If you, for example, print a flap on a 3D printer, you need to make sure that the tolerances and also the certified measures are maintained also by the new part, because otherwise you'll not be able to mount that, for example, on your aircraft. And the predictive monitoring system is exactly doing that by using the sensors in the printer, for example, and putting analytics on top and detecting anomalies and also doing porosity analysis. Especially now in the times of COVID-19, our M4AM, as explained before, can help to ease disrupted supply chains. What we experience nowadays is that we have a lot of globalized and also cascaded supply chains with many different players in there, and with travel restrictions in place, but also strained supply chains and limited ways of transportation. Additive manufacturing can make a difference. That is to substitute procured parts and components by using additive manufacturing instead of procuring them. And therefore, what you can do is, first of all, you can find out what are parts that are suitable for it, and also what's the business case behind it, and therefore find out what you can turn into additive manufacturing. Also, what we can do is support our clients in creating 3D models, because that is the base for additive manufacturing, and we can also prepare, the parts specification checklist to identify suitable printing service providers in case the customer does not has only limited own capabilities and capacities to find them on the market. So this can be done remotely, doesn't have to be on site. And so that also is easing, is easing the process here in the way that we can do it remotely instead of having to be on site with the client. So that was the first overview, and then my colleague Raul will then go into more details on the next slides.
Thank you, Stefan. Thank you for the handover. I would like to introduce the building blocks of the Atos solutions, both Atos solutions, AIP and PMS. We are starting with the AIP solution on the upper left corner. First, there is a space for companies like OEMs, end users, factories, external printing services, others, and other roles. All of them are participants in the additive manufacturing ecosystems and new business processes. There is a project space to organize the parts, to organize the developments, and to share the project content with the companies of your ecosystem. We have also a parts space where OEMs can upload their components, their libraries of components, creating virtual catalogs of parts. We have also a users space, of course, to give all the users of the platform permissions for performing actions on the solution. We have a machines space, quite very relevant, to create the distributed network of 3D printing machines linked to the companies, and we can here indicate the key features of the machines and the capacities to establish the network, the manufacturing network. We have then we go to an area for requests and jobs, where users or requesters, companies that need cover a demand of parts, can order parts from the virtual catalogs uploaded to the platform, and here the network of factories receives the request and assign jobs to the machines. After that, we go to the printing sites, to the factories, to see the second Atos solution, the PMS, the Predictive Monitoring System. The PMS solution is used to provide monitoring and predictive quality tools at the shop floor, at the machine or factory level. And finally, we have a blockchain service covering all the solution to ensure the traceability and protecting the intellectual property of the designs. We will see later on demos more details. I would like to comment also some details about our connectivity solutions. Atos has designed and implemented an edge solution, edge architecture, to connect industrial 3D printing machines to the cloud. This Atos Edge solution has two main purposes, two main uses. The first is to capture and process real-time data from machine sensors to detect anomalies. And the second use is to run analytics, advanced analytics, on the edge over the laser kinematics for quality purposes. We use OPC UA, REST, and other standards protocols in the development. One important thing would like to remark is that Atos solution is machine and IoT agnostic. We have connected EOS machines so far, and we have developed two IoT connectors, one for Siemens MindSphere and the other one for AWS IoT. And our idea is to increase the number of companies, of machine manufacturers, of IoT platforms engaged with the Atos solution and with the standard connectivity. I pass the word to Stefan again. Thank you.
Yes, thank you, Raul. So I would like to give you a short overview about different use cases in different industries where our solutions are applicable. That ranges from defense into automotive, for example. So we find it in medical devices. That is quite a promising area because of the fact that we can, or the companies that are working in that industry can individualize the parts that they are producing, for example, hip implants and other topics, and that is much more possible and more suitable by applying additive manufacturing here. Also in defense, you can imagine the spare parts case, for example, that you have maintenance units in barracks, but also in the field that are using additive manufacturing in order to print spare parts on demand. The same is true for transportation equipment, rail, marine, on a container ship, where you only have a limited number of parts. And by implementing or by installing 3D printers and using the platform and also the PMS, that could also be an ease and avoid, for example, unnecessary stops in ports, for example, to do a repair shop. Same is true for infrastructures, industrial equipment. They say, okay, for example, I have a gas turbine in a power plant. So in the future, I want to produce, for example, the blades myself. Yeah, instead of procuring them from Siemens or other providers. That should be also a market that is a feasible application. Automotive as well, where we also have the use in the new parts manufacturing. Some of the OEMs are already applying additive manufactured parts to their cars, but it could also ease the spare part situation. And a market that is very interesting to them is then also the, for example, the vintage car market, where you don't have or scarcely have spare parts, and that can then be printed, and therefore assuring the possibility to fix cars here, to repair them. Yeah, energy and utilities I've already mentioned. Aerospace, I've also quoted one of the examples, which is the airline industry, which is quite concrete. Atos, a few years, was part of a project called Repair, where that was exactly proven that this will work. And so Raul has already outlined how this is going, how the IP is protected, and how this can be managed by the platform. So what are the major benefits here that we have? First of all, for the product itself, any kind of redesign can be made very quickly because of the fact that we can work on the 3D models here, and we can also simulate that before printing. We can reduce direct cost and testing of additive manufactured parts. And we can also reduce the time to market, for example, when we're using it in prototyping. But we can also reduce the time and resources that we need for the certification of the parts, because we can assure that, for example, through the PMS, we are staying within the limits that are set by the authorities. We can also enable the traceability of 3D printing process, because that is monitored by the PMS, and we are also can assure that the IP of an OEM is protected, although the spare parts is now printed by the customer. For the services, The customers will gain flexibility because they're only printing on demand their spare parts. They can also reduce storage and inventory of the spare parts because they don't have to store expensive parts, and that has also an influence on the capital cost and on the working capital here. We can secure a homogeneous network of printing processes and services that are governed by the platform. We have the full traceability of the 3D printed parts. And we can also increase, the customer can increase the digital services catalog for their customers here. So that is all in the benefits that you can realize by applying our offerings. And I will now hand over to Raul again to have you have a look into the videos and the demos.
Thank you, Stefan. We are going to show some videos, two quick videos, and starting with AIP. Please, could we play the first one? Okay, the AIP platform is a solution to manage business ecosystems. The platform is a collaborative space where OEMs, printing service providers, part requesters, and others can join and cooperate in additive manufacturing. For example, we can see OEMs can define projects to organize the parts and upload the catalog of parts, including and components, including 3D files. This way, the virtual catalog can be shared with other companies to enable business process. End user companies, for example, choose parts from virtual catalogs shared with them. They can buy printing rights at the platform and set requests to cover demands of parts, of components. The printing requests are automatically assigned to the closest factory from delivery location. At the factory, we can see here the job manager receives the request, he organizes the demands, can accept or reject demands, and assign suitable 3D printing machines to the request. At the shop floor, now the machine operator visualizes the job list assigned to the machine. They can reorder jobs if needed, selects the job, he can check the part specifications for the machine setup, and after that, he can launch the printing process in the system. For connected machines, and while the machine is printing, the platform monitors the process parameters and provides alerts to the operator. And finally, it's a very important feature. All participants do business and share information in a secured way. This is especially relevant for OEMs because they can share catalogs and 3D models, protecting intellectual property and minimizing liabilities. The AIP solution uses a blockchain service to track and trace the transactions and participants. For example, the creation of new parts, download, upload. We can see here on the screen the trace univocally defined, the hash ID in the blockchain layer. So this is a very, very quick overview in a couple of minutes of AIP. Let's go with the second video about PMS, please. For PMS solution, we come back to the shop floor, to the machine. The machine operators visualize the job list assigned to the machine, and he selects the job to be printed. He checks the part, the specifications, and a very important thing, the type of quality checks that are required for that part. Then the system prompts operator to enter the job setup information, such as the 3D file, the laser exposure file, laser power, laser speed. All these items are key parameters for quality and therefore for the mechanical properties expected of the component. Once the job files and process parameters are loaded, the machine operator can perform the porosity analysis. So the porosity analysis provides a map of probability of appearance of pores of internal defects depending on the laser kinematics and on main parameters. Then the operator views the results and he can detect critical points in the part and adjust setup parameters if needed. Only if the porosity rates are accepted in the system, the operator can start the printing process. This way, PMS provides tools to predict quality before printing to save time and to reduce scrap. While the printing process is running, the PMS gathers real-time data to monitor the process searching for anomalies. PMS uses clustering techniques, combining several sensors from the machine to detect anomalies. This way, the process and chamber conditions are monitored, contributing to the qualification of the part printed. Finally, which is one of the most important things about PMS, is PMS supports the operator in the setup and during the process, using virtual qualification tools and contributing definitely to first-time right manufacturing and zero defects strategies. So this is all from my side. Thank you. We come back to Felix, I think.
Yes. So thank you, Stefan. Thank you, Raul, for this great presentation. We received a few questions, so don't be shy to ask more, while we now will take the time to answer those. So first questions. If there's a customer interested to start testing the solution, is there any trial mode available?
I'll pick this one. Yes, of course. The customers interested in testing the platform can do it by request. Under request, we are now in the process of setting a group of customers, early adopters of the solutions. So please contact.
Excellent. So big chance. Again, don't be shy and raise your hands. Another question. How about the Atos solution? How much can it work together with other enterprise systems? Can you shed a little bit more light on that question?
Yes, definitely. The Atos solution has been designed to avoid overlaps with existing IT solutions in our customers. We are talking about PLM, ERP, MES systems currently running, so we can integrate our solutions in existing IT landscapes.
Okay, thank you. And maybe one more question, a quick one, maybe to you, Stefan, regarding the COVID-19 implications. Anything you can share here, what we learned, any outlook that you can share with the audience, specifically on additive manufacturing, obviously?
Yeah, I think that COVID-19 will be a booster to additive manufacturing because of the fact that of the disrupted supply chains and also sometimes shortages in the parts to be delivered. And so far, the additive manufacturing is a kind of counteraction here. And in my opinion, this will also prevail because the flexibility that you gain with it, and if you build up an ecosystem of partners and own facilities for printing, I mean, you're also suited for future crises which might come up.
Okay, thank you very much. With that, we are at the end of this session. So thanks to everyone for joining us here today about additive manufacturing. The reporting will remain online at the Atos Tech Days webpage for you to review. So please be sure to join the next session on robotic process automation beginning right after this one. Thank you.